Simplify and state the restrictions. Now here we have a rational expression where the denominators are factored except for the second term. Let's begin by factoring the denominator here of the second term, difference of squares. Now doing that, here we have x plus 1 times x minus 1. Next we need to determine a common denominator. The LCD, or the least common multiple of all these denominators, is x plus 1 times x minus 1 squared. So for the second term, it looks like we need to multiply by the factor x minus 1 in the numerator and denominator. And then we'll have x plus 1 times x minus 1 squared. Now for the first term, it looks like we need to multiply by x plus 1. Now let's take care to place the x plus 1 that was already up there in a parentheses. That'll remind us to apply the distributive property. Now that we have a common denominator, we can then subtract the numerators and write the result over the common denominator. So here we have x plus 1 squared minus 2 times x minus 1 minus 4. Now at this point we're left to simplify the numerator. And in this case we have x plus 1 squared. When we multiply that, we get x squared plus 2x plus 1. Distributing this negative 2 leaves us with minus 2x plus 2, and then minus 4. Simplifying further, we're left with x squared, 2x and minus 2x add to 0. 1 plus 2 is 3, minus 4 leaves us with x squared minus 1, which we recognize again as difference of squares. And so at this point we'll factor the numerator, and we have x plus 1 times x minus 1. Now at this point we can cancel common factors, but before we do that, we should identify the restrictions to the domain here. Whatever evaluates to 0 in the denominator is a restriction. So it should be clear that x cannot equal 1. If it is, we'd have 0, or negative 1. So we'll write x cannot equal 1 or plus or minus 1. Now then, at this point we will cancel. So the factor x plus 1 divides out, and the factor x minus 1 divides out. And when the entire numerator divides out, we're always left with a factor of 1. And so therefore we have 1 over x minus 1. And the original expression simplifies to this where x is not equal to plus or minus 1.